question one. Find the general solution of this system. This is x bar differential, and then we have this one as a according to the standard form. This is matrix A, and this is a vector. To find the solution, there are steps to be followed. Step one is to find what? Find the eigen values. That's step one. And to do that, we need to solve this expression, which is a determinant of this. Okay? And this dots mean this is a line, this is a symbol for determinants. Okay, and this matrix A is a 2 by 2 matrix. So, which means this expression here mean this is the leading diagonal. So, the leading diagonal minus what? Minus R minus R. My R is what? Is the eigen value. So, and this will be what? This will be minus 1 minus R 2 minus 1 and then minus 3 minus R equal to 0. So this expression is the content inside these two lines. And what to solve 2 by 2 determinants is going to be this one times this one, then minus this one times this one. So minus. So we have minus 1 minus R times minus 3 minus R, and then minus this one times this one is minus 2. So it becomes what? Plus 2 equal to 0. So this times this will give us a 3. This one also times this one will give us what? A plus R. Then this one times this one will give us what? Plus 3R. And then this one again times this one will give us what? Plus R squared plus 2 equal to 0. Okay? And if you look at this 5 now, the factors of 5 is 5 and 1. There's no way you can use 5 and 1 to get plus 4. Okay, so we can factorize this expression. So what we do is to use quadratic formula, and that will be R equal to minus B. Is my B is 4. In this case now, A is 1. That's an attachment to your R squared. B is what? B is 4, coefficient of R. And C is what? Is the constant value. Minus B plus or minus B squared minus 4AC all over 2A. So that's the formula I'm using. So we now have R will now become minus 4 plus or minus. This is 16 minus 20. That's minus 4 over 2. That gives us R will be equal to minus 4 plus or minus 4 is equal to square root of 4 and then times what? Square root of minus 1. And that will be 2 watts. The square root of minus 1 is complex number, is I over what? Over 2. So take 2 out here. If you do that, factorize that 2. So that is our eigen value, which is a complex number. And don't forget the real part is the alpha. The imaginary part is what? Is beta. So beta is what? The coefficient of what? Of your R, which is what? Which is 1. Okay? Then the next thing to do now, step 2, to calculate eigen vector. We're going to use like solving. So that's the expression we're going to solve. So how do we solve this expression? It's very simple. This expression here, you just come back here. Already you have the value for R now. Okay? And don't forget this value, I'm going to use to save the time, I'm going to use just one of these values. I'm going to use minus 2 plus R as my eigen value. I'm not going to do the 2, I'm going to take 1 minus 2 plus R as my eigen value. So just substitute, come back here and give you substitute for your R. Substitute for your R. Okay, what we are doing is just this expression means the leading diagonal minus what? Minus the eigen value. That will be equal to what? Minus 1 minus 2 plus what? Plus I. Then 2 minus 1 minus 3 minus 2 plus I. Okay, close this. Okay, then this one is z is the eigenvector, and that's what we are looking for. The component of that will be what? Z1, Z2. Okay, so if your matrix is 3 by 3, so it will be Z1, Z2, Z3. But in this case now, our matrix is 2 by 2. So I'm going to have Z1, Z2 as a component of Z. Let's get the value of this. So that's what we have now. Then the next thing to do now is to do the augmented matrix. And that is what? That is 1 minus I, 2, minus 1, minus 1 minus I. Then you put your slash, 0, 0. So we are combining this matrix and the equal value. Then the next thing we want to do now is to do the row operation. Okay, and what we want to achieve is to have, at least on the second row, to have 0 here, or everything on the second row to be 0. So that was our target. So what we do is this: we're going to use the row 1, what you have here, the first element here, 1 minus this, times the conjugate of this expression, which is 1 plus this. Okay? So if you multiply, it's going to give you 1 minus I squared. And that's what? That's 2. And what I have here is what? Is minus 1. So that means I can divide this expression by 2. And that will give me what? That will give me 1. Okay? So in that case now, root 2 is equal to root 2. Since this is minus, then this one is what? Plus with this algebra. So plus 1 plus I, okay, times root 1 over what? Over 2. And that will give me, 1 minus I at 2, and then this will be 0, but this is minus 1. And then with this expression is what? It's also 1. So minus 1 plus 1, that's 0. Here also, if you do the algebra, it's also equal to 0. And then this one minus this is 0. So let me show you how we got this one displaced with 0. Let me show you. Very simple. You have root 2, which is what? Minus 1 minus I. Okay, then plus 1 plus this times root 1. Root 1 is what? 2 over 2. So this one will cancel. And you can see now plus 1 minus 1 cancel. Minus I plus I. So with this now, I can now turn this one to expression, which will be row 1. I'm using the first row. That will be 1 minus I times Z1. Okay, plus what? 2 times what? Z2. Got 0. Okay? Don't forget that Z1 is for the coefficient of what? Of first column. And Z2 is the coefficient of what? Second column. It will be this one times this one. That's Z1. This one times this one. Minus I Z1 plus 2 Z2 equals 0. Then, so the Z2 is equal to what? Is equal to minus 1 plus I over 2 equal to what? Z1 or Z1. So let's consider Z1 to be S. So Z2 is now equal to what? Half into brackets minus 1 plus this. Okay? So the eigenvector will now be equal to the eigenvector will be equal to, which is at Z1 and Z2. The Z1 is what? Is X. Z2, you can open this one, which is what? Minus half X, and then plus half I So Z2 is the combinations of real parts and the imaginary parts. So we can break this one into two parts. So the eigenvector is equal to the real parts, and then we can factorize the x, and take the x outside. That would be what? That would be 1, and that would be what? Minus half. Okay? Then the imaginary parts, take this ix outside, the imaginary parts be equal to what? There is no imaginary part here, so that's 0. And this one is what? Is half. So that starts on this case. So if you take your x as 1, conform to a plus I b. Okay, now conform to that. So this is our a, and this is our what? This is our b. Okay. Then the next thing to do now is write the solution. The solutions are the first one is equal to will be exponential. The alpha is minus 2t cos beta is 1, so cos t, and then times a. My a is what? My a is 1 minus half, then minus exponential minus 2t sine t, and then b, vector b is 0 half. Okay, don't forget the eigenvalue we have, which is minus 2 plus I. So that's the eigenvalue we are using. So that means what? The real part is the alpha, the coefficient of I is beta. And the second solution, the second functions of t, the second solution will be equal to, you start from here, that exponential minus 2t sine t, then your a, that's 1 minus half, then plus exponential minus 2t cos t, then 0 half. So that's the solution for this. The general solution is this, the functions of t equal to c1 x1 as the functions of t, then plus c2 x2 as the functions of t. So these are the general solution. Just plug in there, and that is the end of this question. I want to see, before I go for this question, please, there is an icon on the video. Click on it and subscribe. Okay, and click on like button across our videos. Okay. On the final notes, begin to share this video on your social media platform, on Facebook, on Instagram. Begin to share the links of this video on your social media platform, on Twitter, on your WhatsApp. Let this video go viral. Okay, begin to do that right now. Okay, begin to do it right now. Thank you for doing that. Join the next question. That's question 2 on how to solve complex eigenvalue. Okay, next question, question 2.